That is to say that z squared is equal to r squared cos 2 theta plus I sine 2 theta, and z is equal to r cos theta plus I sine theta, wherein I'm missing my lovely I here. So let's get a darker color for that one there. Now, in these circumstances, what we're going to do is we're going to say, now let's consider what if, instead of having squared, we can have n, so that it's any number, where I'm going to also suggest that n is an integer, and therefore we'd have Zn equals Rn cos theta plus I sine theta n. That is what we're going to look at now. Because if we can know that, then we can start tackling such things as things wherein we have much larger powers coming up in our problems, for example, to the power 5, which we'll need to utilize at some point later. Now, what I'm going to do is I'm going to say, well, let's just consider this part. If you bear with me for one moment and consider this part. So may we let n equal 1. So I'm going to let n equal 1, and hence, therefore, we will start with cos theta plus I sine theta is equal to 1. We are very much aware that this means cos theta plus I sine theta. They are the same thing, but I put the 1 in front to illustrate that there was a pattern that we might be coming across, which is that when it was 1, there was no coefficient of theta, but when it was squared, there was a coefficient of 2. So we are going to assume that, therefore, whatever this power is, it will be equivalent to what the coefficient is, and that would be very advantageous if that were the case, and we could show that that were the case. Now, thence I am stating that that might be the same here, in that we have very comfortably a 1, we have a 1 here, and so I'm assuming that perhaps we should illustrate that a secret hidden 1 will be stood in front of our theta. Okay, we know this is true, so let us assume that it is true for n equals k, k being an integer, and I'm going to assume that it is true in that I have knowledge that for me it should follow that pattern. Let us assume it is true for n equals k. So it's done for 1, we've proven that. Let's assume that k being an integer, it is also true. So cos theta plus I sine theta k, just by way of pattern, that is the knowledge that I'm trying to utilize, my understanding of pattern, that there would be a k, if there was a k as a power here, then there should be a k as a power in front of the theta. For example, if k were 1, n equals 1, we'd have 1, we've shown that, this would be the case. If k were 2, n equals 2, then we'd have 2, and we'd seen that we've done that as well, z squared would be r squared 2 theta sine 2 theta. So for k being an integer, we're just going to assume it as any value and assume this is true. But what is most important then is, why don't we analyze the degree to which we have n equals k plus 1, one step higher than whatever value of k we decide. So if we decided k was 1, k plus 1 would be 2, which would be r squared. If we decided k was 2, k plus 1 would be 3, which is something that we haven't analyzed yet. It would be, what would z cubed be?